Hey everyone, in this video we are going to be solving the work of changing velocity. So in other videos we've looked at solving the work of lifting an object up into the air. Another way of solving work is if you're pushing an object and applying a force. At this one we're going to be looking at changing the velocity of an object. Let's get started and find the key terms. A 75 kilogram basketball player leaps into the air with an initial velocity of 4 meters per second from a standing position to make a jump shot. How much work did the player do to achieve this jump velocity? When we're solving the work of changing a velocity, just like in changing height, we use the equation that work is equal to our change in energy. Only this time, our change in energy is kinetic energy. And the kinetic energy equation is energy kinetic is equal to 1/2 mv squared. So that's what we're going to be using to solve this. Our work is equal to our energy final after they jumped, subtract our energy initial before they jumped. Well, the energy initial is not so bad because the energy initial, they haven't jumped yet and they're in a standing position. So I underlined standing position. That's important because we have 1/2 times 75 times 0 squared. It's just going to equal 0 joules. They haven't done anything yet. And our energy final is once they've unleashed those powerful muscles and launched themselves into the air. And we care only about that exact instantaneous velocity at the moment they leap. 4 meters per second, and that's going to equal 600 joules. Now that we know the energy of our system before and the energy of our system afterwards, we can come over here and say that our work equals our energy final, 600, subtract our energy initial, 0. Our work is going to equal 600 joules. Take note that this is positive. This is positive work because we have increased the energy of the system. The basketball player went from not moving to now moving fast. We have increased the energy, and that's going to be important when we look at our second example here. So in our second example, a superhero wishes to stop an out-of-control truck with a mass of 1850 kilograms. Underline that is moving at 120 kilometers an hour. Solve the work done by the superhero on the truck. This is an example where we're looking at a change in velocity, which means our work is going to equal our change in energy. The only difference this time is that we're going from fast to slow instead of slow to fast. Our work is still going to equal our energy final, subtract our energy initial. Let's go ahead and solve our energy initial. Our energy initial, which is kinetic, is going to equal 1/2 mv squared. Our energy initial, hold just one moment here because there's a little shenanigan. The little shenanigan is that you've been given your velocity in kilometers per hour. And these equations work in meters per second. So I hope you picked up on that and realized that you had to take that 120 kilometers an hour and divide it by 3.6. That is the conversion factor in order to go from kilometers per hour into meters per second. And it's going to equal approximately 33.33 meters per second. If you forgot to do that conversion, the work here is going to be phenomenal. That number would be magnificently huge. It's already going to be really big anyway because we're stopping a truck. The mass is 1850. Our velocity is the 33.33 squared. And like I said, this is actually going to turn to be a really big energy no matter what. Because if you fill this in, and I kept all my decimals, I didn't just round here. So if you're wondering why mine might be slightly different than yours, that's why. It's going to work to be a little over 1 million joules. A little over 1 million joules. Energy final, that's a lot easier because it's 1/2 times 1850 times 0 squared. The superhero stopped the out-of-control truck, saved the day, everyone loves them, heralded by all, 0 joules. I go back over to my work. Hopefully I'm going to have enough room to put in a number even this big. It's going to be 0, which is our energy final. Subtract 1027778. Like I said, a little over 1,000,000 joules. Our final answer is that our work equals, negative 1027778 joules. Now it's going to be approximately, this is great, negative 1.03 megajoules. You can give the answer either way here for me, but what's important is that negative. Why is the work negative this time? It's negative because the superhero took energy out of the system. The truck was going fast, and now the truck has stopped. That's what negative works means, and the hero is absolutely allowed to do negative work if it means stopping this truck and saving the day. I hope that this was helpful. Good luck with working on this type of problem where you're solving work by changing velocity. If you have any questions at all, please feel free to leave them in the comments below.